Okay, Assalamu alaikum wa rahmatullahi wa barakatuh. So we will start our show, the Planetarium show, in the occasion of the World Space Week, WSW. And now it's the time to go from the Earth through the solar system, and we choose one planet, one important planet, the red planet, which is Mars. Fatima Al-Khatri and Ahmed Salah al-Din are members in the planetarium who will take us through this journey. Please start your show and tell us something about the Hope prop, the Emirati mission to Mars, and also we need to know something about Mars orbit and how to go there, and also would like to enjoy the sky itself, the constellations, and the solar system. Are you ready?
Assalamu alaikum wa rahmatullahi wa barakatuh. Yes, we are ready now and start from the journey of the red planet. Also, we'll talk about the mission that was supposed to that is going to be reaching, inshallah, the beginning of next year to Mars from the UAE, called the Probe of Hope. With me, I have my colleague Ms. Fatima Al-Khatri, who shall be taking you in a depth of information along with the Probe of Hope. We shall first begin with not the Mars, we shall first begin with the Earth itself. So here we have a short landing scenario, and then we shall look at the sky of Sharjah, and we shall see the visible objects, including the stars and the planets, in the sky of Sharjah. So now let's land where we call home, the city of Sharjah. So this is the sky of Sharjah as if you're looking at from Sharjah. And obviously the sky of Sharjah will be not showing you any stars or any objects like that, because we are during the daytime, we're looking at the sky. So we'll have to look at the sky during the nighttime. For that, we're going to simulate a forward time scenario so that we can see the evening time of Sharjah. So in this scenario, you can see the sky will be getting darker soon. And as the sky gets darker, you'll be able to see a lot of stars in the sky of Sharjah. Here it is, the view of Sharjah during the nighttime. Obviously, in the past, the astronomers or the travelers in the past, they used to depend on the stars to know directions. And that's how they figured how to find the northern direction, for example. And now we'll show you a scenario to find that. Before that, we shall appreciate the view of the sky, how we can see the Milky Way galaxy's visible spectrum here. That is called the area which is visible to us with the naked eyes without telescopes. But obviously, if you have telescopes, you'll see deeper and the depth of the Milky Way galaxy, which is filled with billions of stars and a lot of stardust in the neighborhood of the galaxy. Let's now see how the ancestors connected lines between the stars. For example, we take an important constellation here, but during this time of the year, we'll not be able to see the entire group of this constellation. It's called Ursa Major. And this small part of the Ursa Major is called the Big Dipper. So Big Dipper is not completely visible. So we go to another one, which is also giving us the same exact job that Big Dipper does, which is Cassiopeia. So both these group of stars, this is a constellation and this is an asterism. Both of them give you a very important star, very important directional star, which is called the Polaris, or the North Star, or the Pole Star as we call it. From both of these groups, from Big Dipper, we can draw a straight line like this, we can find it. From Cassiopeia, we can draw this kind of a scenario, or this kind of a design, and we can actually reach the important star called Polaris. Polaris is very important because it always stays at almost the same position from Sharjah. So if this is the horizon, 0, and about 25 degrees, which is almost the latitude of the city of Sharjah, is where Polaris is almost all the time. Actually, most of the time, because it never changes position according to us. And it's going to be our pole star for a lot of years coming up, and then the pole star is going to shift to another star called Vega. So pole stars are not fixed in its position or its designation. It keeps changing depending on the motion of the Earth precession circle. Now, these are the two groups of stars that can help us to find the pole star, but we are interested in the rest of the groups, more like the constellations that we know. There are zodiac constellations and there are the ordinary constellations. All of them together form a very nice map for the sky, actually, a very nice gallery of images for the sky. Let's now look at the groups of constellations. There are 88 constellations, but we cannot see all of them from Sharjah because Sharjah is above the equator, and any city above the equator will have their specific constellation that's visible to us. If you go to a city below the equator, to the southern hemisphere, then the scene changes because you can see more constellations there because that's the southern sky. Sky is different when you travel from place to place on the earth. Even in Sharjah, for example, we go back to the same thing. Polaris is about 23.5 degrees or 24 degrees. If you go to another city, it will shift. If you go upwards to London, to Norway, it's going to shift all the way there. But if you go to the south, it's going to be below 0 to another hemisphere. Let's now look at the constellations, the groups of the constellations. We have 88 of them. And here we can see some of the constellations. And now we shall try to figure out the images for these constellations. Not all constellations have the same images, but these are the mythologies and theories that come up from all the way from the past, from the civilizations, from the Roman, the Greek, the Chinese, Indian, all the civilizations. The Arab Muslim civilization had a lot of contribution in figuring out a map for the sky. And even today, we use these constellations for many benefits. Number one is for constellation directions, but we have GPS and devices now. But even then, there are travelers that actually look at the sky and they wonder about the directions using these stars. Also, the farmers used these constellations to know the beginning and ending of seasons, winter, summer, and the weather conditions. They used to predict it by looking at stars and knowing which constellations are visible now. So it's winter time, or is it summer or autumn or spring? And these constellations, for example, this is Hercules, and we have Cygnus, Lyra. This is Vega, by the way, the star that I mentioned earlier. So we can see the shifting is going to be from this star to this star, which is the Polaris, which is the pole star of the next pole star in our sky. So the shapes of the constellations are interesting because they are the ones that was imagined by the ancestors, and they drew them down like real good figures. And these are the constellation figures, as you can see right now. And from here, we shall move to a journey that is going to be quicker than the time journey that we're traveling right now. We're looking at the constellations. We're going to be looking at the motion of ourselves in an imaginary spacecraft going all the way from the Earth, the planet Earth, and then we shall visit the the fourth planet, which is the red planet, Mars. You can see the yellow constellations. These are the zodiac constellations. As you can see, Gemini is here. You can see Taurus. And these are the constellations through which the sun, the moon, and the planets move through. A line is called the ecliptic line that passes through these constellations. That's why we've given it the yellow color. You can see the months here. You can see June, you can see July, August. Depending on the month where the sun is, these are the constellations that are visible. Here we can see Leo, almost in the constellation of August, the 8th month of the year. And that's the end of the constellation journey. And now we shall go for a journey in space from Sharjah all the way to the outer space. Listen to a short countdown.
35 seconds and counting. We are still 30 seconds and counting. T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running.
We have now successfully reached the outside of the Earth and the atmosphere. We have escaped more than a few thousands of kilometers. And now we're looking at the entire planet, the Earth. From here, we shall start our space journey, which is going to be from the Earth to the edge of the visible universe. On the way, we shall take a stop break at Mars and look at the planet, and then we shall go to the edge of the galaxy. The first orbit you will see will be the orbit of the Moon, which is the closest object to the Earth, the natural satellite, the Moon, which is right there. And the stars that you see are actually the stars of the Milky Way galaxy, which will not move any soon because we are still inside the vicinity of the solar system. We have to leave the solar system to see the stars moving. I'm going to enlarge the planets to 1,000 times to make them clearer from this distance. We can already see the planet Mars in the background getting bigger. And you can see the other orbits of the other planets. Also, now we're going to be seeing the belt of asteroids in between Mars and Jupiter. There are more than 1.5 million asteroids in this belt of asteroids. Ceres used to be the biggest one, but now Ceres is classified as a dwarf planet. So now the biggest asteroid position is given to an asteroid called Vesta. Ceres is about 950 kilometers in diameter, so you can imagine how big that is. So Ceres is now joined with other 4 dwarf planets, including Pluto, which are there in the Kuiper belt that comes beyond the orbit of Neptune. We shall see that once we get to the other edge. Now let's visit the 4th planet, the interesting destination that we have. And the 4th planet is actually the hope for humanity to land on another object other than the Moon. Because if you look at the other side, it's Venus and Mercury, but Venus does not give you any hope for landing because Venus is the hottest planet in the solar system. We can't be landing on Venus because the temperature can get up to 460 degrees Celsius. So you can't imagine doing that because at around 40 degrees Celsius here, we're like, we don't want to get out, we want to stay home. So Mars is actually the hope that gives us to be living there. That's why we even call the probe that we sent from the UAE, we call it the Hope probe, because Mars is the next hope for humanity from the Earth all the way there. So the distance of Mars from the Earth, now it's very close because the window in which we sent the probe to Mars was in July in 2020, which is the best time because Mars was going to be flying by closely. So before Mars gets close to the Earth, we send the probe so that the probe can catch up with Mars. This information will be discussed in detail by our colleague, Ms. Fatma, who shall be explaining to you all about the probe or Hope probe, which is the satellite that is going to be reaching Mars in 2021. Surface of the Mars is actually red in color. As you can see, the red color comes from the oxide of iron on the surface, and that reflects the light, and the light takes up that light and shows that to us. And there are many craters that you can see, but geologically, this planet is not as active as the Earth or Venus. Most of the volcanoes on Mars are dead. All you can see are craters, which are called the volcanic craters, not like the craters on the Moon, which are the impact craters. The highest peak in the solar system is actually does belong to Mars, which is the Olympus, which is about 3 times the height or the height of the Mount Everest, which is about 22 kilometers. That's the highest peak in the entire solar system. You can see ice caps, you can see canyons, you can see craters. So it's almost giving you a feeling that it could be the next host for life. So let's hope for the best, and let's hope we land as human beings on Mars during this generation so that we can enjoy the sight of human landing on the planet Mars. Let's now leave the solar system behind and let's go flying through the gaseous planet orbits, Jupiter, Saturn, Uranus, Neptune. Also, we'll look at something called the Kuiper belt, which is also a place where there are asteroids, a few comets, and also the 4 dwarf planets. But the solar system does not end at the Kuiper belt, not even at Pluto, but it ends at a point called the edge of the Oort cloud, which is about 1 light year across. And that edge is the ending of the solar system and the last place where the sun's gravity is impactful. So the 8 planets, 4 dwarf planets, millions of asteroids and comets, that is our solar system at the end. And now we shall see the Oort cloud, which is the main source of comets. And from there, we shall see the stars moving slowly. That means we are crossing more than 4 light years across. That's the distance of the closest star to us, Proxima Centauri. In the next section that we're going to talk about is the big home in the universe, which is the Milky Way galaxy. And here I give the mic to Ms. Fatma Al-Khatri, who will be telling us more about the galaxy.
Thank you, Ahmed. As we know that galaxies are divided into 3 main types according to their shape. We have spiral galaxies, irregular galaxies, and elliptical galaxies. And also spiral galaxies are divided into 2 main types. We have spiral barred galaxies and spiral ordinary galaxies. And our Milky Way galaxy is a barred spiral galaxy containing of 200 billions of stars with a diameter 100,000 light years across. That means if we send a beam of light from this edge to the light will take 100 years to reach to the opposite side. And all the stars in the galaxy are dominated by a massive black hole. And the black hole is the place in space where the gravity pulse is so much that even light can't get out. And the gravity is so strong because matter has been squeezed in a tiny space. And this can happen when a star is dying. Um, before 100 years ago, as we know, our Milky Way galaxy represented a whole universe. However, in 1924, American astronomer Edwin Hubble used his own telescope to observe billions other galaxies beside our own Milky Way. And all the galaxies are moving away from each other. And this suggested that the universe is expanding. And as we move away from the galaxy now, we will notice that all the galaxies are moving away from each other. And now we will move away from the galaxy. We will notice that every dot of light represents a galaxy, and all the galaxies now gathering together to form a supercluster of galaxies. And as we know that the universe began 13.8 billion years ago in an explosion so powerful that space itself propelled outwards. Even atoms could not exist in this hot fireball. 380,000 after bang, hydrogen atoms formed, and 200 million years later, the first stars formed. And put on your mind, every atoms in our bodies came from a star that exploded. So we are all stardust, and we couldn't be here if a star hadn't exploded, because all elements, hydrogen, carbon, nitrogen, iron, and so on, all things that matter for evolution and for life, they were not created in the beginning of time. They were created in the nuclear furnaces of a star. And you can see now what we called this microwave background radiation. This is the thermal black body radiation emitted by the hot dense gas formed in the Big Bang. And this CMB was discovered by Penzias and Wilson in 1964, and they received the Nobel Prize in 1978. What you are seeing now is called the visible universe, which is 90 billion light years across, so far, and no human has ventured more than 1.3 light seconds from the Earth. This is our journey till the edge of the universe, and now we shall return back to the fourth planet, Mars, to take a look to Hubble. Thank you, Ahmed. Now I will share my screen. Today I'm going to talk about the Emirates Mars mission, the Hubble probe. It is the first UAE probe sent to Mars, as we know, in July 22, and the first ever Arab mission to study the Martian atmosphere. And this project gives the UAE a new hope, as it is a prize for the country's 5 decades of development and hard work in a various field. It is also a reflection of the version of UAE's wise leadership. As you know, the launch window, we have a launch window, a specific time to send a probe to Mars, and this we called the launch window. So as you can see, the launch window occurs only once every 26 months, 2 years and 2 years and 2 months, when the distance between the Earth and Mars is the shortest, which makes the journey easier. And at this time, the distance, it is about 493 million kilometers. This is about the launch window. And you can see here, this is the Hubble probe, and it will reach Mars, inshallah, in February 2021. And as you know, the Hubble probe set off from Japan, specifically from Tanegashima Island, in a 7th month journey to reach the red planet. When the probe will reach orbit of Mars by February 2021, it will remain on orbit for 1 Martian year, about 687 days. The Hubble probe will not land on the surface of the Mars. It is an orbiter. There is a scientific and a specific objective for this probe. As we know, the Hubble probe will be helping us to answer important scientific questions that no previous scientific mission has ever raised before in the field of the red planets exploration. And the scientific team of the Hubble probe seeks to identify the reason of hydrogen and oxygen escape from the upper layers of atmosphere of Mars. The team of Hubble probe will study the changes that occur in the atmosphere of Mars during its daily and seasonal weather cycles. And this would provide the scientific community with large amount of new information about the weather of red planets. And you can see here His Highness Sheikh Mohammed bin Rashid and His Highness Sheikh Mohammed bin Zayed. So our leaders proved to us that nothing is impossible, that no matter how big our dreams are, and we can achieve them. You should focus on achieving your dream what I'm going to say, your dreams and my dreams, we can achieve them in UAE with our leaders. This is about Hubble probe, and now let's start astronomical competition with Ahmed. Take the mic, Ahmed.
Thank you, Ms. Fatma. Now we should start a few questions. We'd like you to join paulev.com/SAST360, which is right there on the top. That's the link you should enter through your phones, so in which we can have a quick competition. Once you enter, just enter your name and you will be able to see the questions. Totally, Fatma.
The first question.
The first question is, which one of these is not a shape of a galaxy? It's not a shape, remember? So we have 4 different shapes. And which one of these do you think is not a shape for the galaxy? To join again, you should use the internet browser on your phone. Just type www.paulev.com/SAST360. SAASST 360. And that way you should be, Fatma, can you please stop the time? Pause the time. Thank you. So let's make sure everybody joined the poll. The question once more, we have, which one of these is not a shape of a galaxy? We have the option 1 is barred spiral, the option 2 is helical, option 3 irregular, and option 4 is elliptical. We have 2 answers. Let's wait a little more for more answers. Kindly do not write the answers in the chat box. Make sure that you enter the poll through the application, through the browser on your phone, and then please answer it on the app. Thank you. So the correct answer for this question is helical, because helical is not a shape of a galaxy. The 4 shapes we have are irregular, elliptical, barred spiral, and spiral ordinary galaxies. So that's the 4 shapes. Helical is not one of those shapes. All right, now we have the next question. Question number 2 says the diameter of the Milky Way galaxy is estimated to be from one edge to the other edge. We mentioned it during the journey through the galaxies. The options, number 1 is 100,000 light years. Number 2 is 100 million light years. Number 3 is 100 million kilometers. So as you know, we measure distances in the space using light years. So how many do you think, how much time will light take to go from one edge of the galaxy to the other edge of the galaxy? That is the correct answer. It's 100,000 light years. Yes. Question number 3 says, how many constellations are there in the sky? We watch the constellations during the stargazing time. So are those 12 constellations or 44, 88 or 99? How many constellations are in the sky? 12 or 44, 88 or 99? The time is now up and we can see the answers. The actual answer, the correct answer for this question is 88 constellations. We have 13 zodiac constellations and the rest of it are the normal constellations. So from the northern and the southern hemisphere together, we have 88 constellations. Question 4 says the mean distance of the Earth from the Sun in AU is equal to. So what is 1 AU, 1 astronomical unit? That's the question. That's the mean distance from the Sun to the Earth. So is it 150,000 kilometers? Is it 150 million? Is it 150 light years? Is it 150 million light years? So think about light year. When does it start? Think about AU. And how many kilometers do you think, or how many light years do you think is 1 AU, which is the mean distance between the Sun and the Earth? That is right. The correct answer is 150 million kilometers, which is the average distance between the Sun and the Earth. Let's go to the next question. Ms. Fatma, would you like to take this one?
Okay, the Hubble is now heading to the moon, will orbit around it. The moon will land on it. Mars and will orbit around it. Mars and will land on it. Okay, let's see correct answer. Mars and will orbit around it because the Hubble probe is an orbiter. Ahmed?
The next question is the sixth one that says the launch window for travel to Mars repeats every how many years? Fatma had mentioned that during the explanation for the Hope probe. When was it launched? So you can see in this picture on the left-hand side, there's a specific time in which the Mars mission has to be launched. That is the window that you see. And exactly at that point, how many of those windows show up in how many years and how often they show up, this window to Mars? The options. The launch window, how many times does it show up in 1 year, each year, or does it show up in a year and 2 months? Or does it show at 2 years and 2 months? Or you cannot know these things because it's not fixed and it can't be predicted. So which one do you think is the answer? how the launch window repeats every 1 year, it repeats every year and 2 months, 2 year and 2 months, or it's unpredictable. We have a chat that says which app, where to answer this quiz. You don't have to open an app for this. You just have to go to your browser on your phone and type www.paulev.com/mark SAASST360 SAS360, and you should enter this quiz through your web browser. You don't have to have an app for that, so it's easy. And once you enter, they'll ask for your name, and you can enter your name and then enter the quiz right away. So we have answers for 2 years and 2 months. Let's see if that's the right answer. Yes, that is the right answer. And now we have 2 people, and then we have Zair. Zair is the visitor who has 1. And now if you have any questions, you can type it down here. So if there is anyone who couldn't make it to Paul EV, if there's some problem with your phone or your browser, you can actually type the question in your chat box. And if there's any question, we shall be answering the questions. So you can put down your questions in the chat box, or you can put it down in the Paul EV page. متى تتوقعون السفر الإنسان إلى المريخ? The question is, when do you expect human flight to Mars or human journey to Mars? The research and the development for this question has been going on for a very long time. And recently, we've been seeing a lot of news from SpaceX. And also, there are projects happening in collaboration with NASA to launch human beings to Mars. But before that, we need to have a lot of test flights and training. So we don't have an exact date for that yet. But 2023 and further, there'll be a lot of advancements in this field. And they're already testing the rocket that's supposed to be taking people from the Earth to Mars, and the test has been uploaded online, so you can watch the test of the rockets. It's a static test for those rockets. They keep it in place and they test the engine power and the engine working and functionality, and to see if there is an error. So if predictable, then pretty much in the next 10 years or next 15 years, you might see a human flight to Mars. They're asking for a presentator's name. You can type in any name. You can just type any name you want. If you want type anonymous name, just type a number or something. You can enter the place, the page. Any other questions? Okay, so in this page, you can type in how did you feel about the show. You can write in one word. You can describe how you felt about the show just to see the feedback. If you don't find the page again, you can write it in your chat box too. It's fine. I don't think someone can describe this in one. Okay, there is one. Shukran jazilan. Thank you so much. We're welcome and thank you for coming in for the show, and thank you. And I hope you enjoyed and benefited from this quick journey and a quick quiz and presentation.
Thank you very much, Ahmed and Fatima, for this nice show. Thank you very much. Thank you for your participation in the World Space Week. I appreciate that.
Thank you, Dr. Ilyas.
Thank you.
Thank you.
شكرا بارك الله فيكم. يعطيكم العافية.
الله يعافيك.
ما في كثير ناس بس يلا شو بنعمل هيك السبيس دائما خير وبركة. السبيس دائما قليل يعني بروحوا الفضاء قليلين.
Space is open for everyone. الحمد لله.
يا بروحوا قليلين. يلا شكرا لكم.
Thank you very much.
شكرا.
Thank you.
بارك الله فيكم.
السلام عليكم.
وعليكم السلام.